Hello, here we're going to be looking at section 1.8, perimeter, circumference, and area. So perimeter and area, let's dive on in. The perimeter of a polygon, this is going to be a shape. You're probably familiar more so with the word shape, but that's what a polygon is. And the perimeter is the sum of the lengths of its side. Perimeter is the distance around the outside of a figure, that very outside edge. And it's measured in inches, feet, yards, miles, meters, etc. as any standard units of measure. The area of a polygon is the number of square units it encloses. Area is the amount inside of a figure. And it's measured in those same units of measure as above, but now that it's a two-dimensional figure, the area, it's not just the line around the outside, it's the area, two-dimensional region on the inside. We'll have inches squared or square feet, yards squared, meters squared, etc. All right, and so we're going to, in this lesson today, be looking at some kind of some introductory level type stuff with area and perimeter. If we're working with a square, here are the formulas for perimeter and area. Perimeter is just 4 times the length of one of its sides, which should make sense because the perimeter is just the outside. So if this is a side, a square has 4 of those. So that's why the perimeter is 4s. Now the area is just going to be one side multiplied by the other, but since both sides are the same, we could have also written here for area side times side, right? S times S. However, it's faster to write S squared. So you'll see that. All right, on here to the rectangle. You'll see here they marked our lines of congruent, right, saying that this side is congruent to this side, as well as this side to this side, and they labeled it as base for B and height. So perimeter is I've got 2 sides for my height, I've got 2 sides for my base, so that's where this perimeter formula comes from. It's just adding up the outside. Area is just going to be multiplying the base times the height, and it'll tell us all of the area on the inside. So that's how it works with the rectangle. All right, so for us here for the triangle, the perimeter is just the all the outside edges added together. Sometimes they'll all 3 be different. They could all 3 be the same sometimes, which will make the calculating the perimeter even easier. But it's A plus B plus C, the 3 sides of the triangle added up. The area, same as the rectangle, except we have a 1/2 in the front. And so we'll kind of see more about that as we move on. But it's base times height. So here's our base, here's our height, except we then need to multiply by 1/2 at the end to get the actual area of the triangle. We'll work a lot with triangles through the year. You'll become very comfortable with the different properties and concepts of triangles. All right, circle doesn't use perimeter. It's going to use letter C for circumference. And you can see here on the diagram, circumference is just the distance around the outside of the circle. There's 2 ways to calculate the circumference depending on which measurement you want to use. The first one here is 2 pi r, r being the radius, which is halfway across through the center of the circle. Right, and if we're going to be using the formula that has r in it, we'll need to multiply it by 2 because it would take 2 r's to get all the way across. And you'll see that formula listed as 2 pi r. The other version is if you know the diameter is just 2 times the radius, or the distance all the way across the circle. I don't need the 2 on this formula. I would just need pi times diameter. And pi is something we're about to explore. It's a button on our calculator. It's an irrational number. It's a certain number, though, that we will look at and use also a lot throughout this year. All right. The area is pi times r squared. All right, pi r squared you'll see. And I put parentheses around that r squared so that you can clearly see what's being squared, only the r. And we'll work with circles a lot this year too. There's lots of different things we can do with circles in terms of finding the areas of little sections here, like a piece of pizza, or finding just little segments right here, which we'll give those a title as we're moving on through the length, through the year as arcs. So a lot of good stuff here. We'll end up having a decent amount of formulas for different shapes, different polygons, bringing that vocab word back in from earlier. But let's continue on here to see what else we've got coming today. Finding the perimeter of a rectangle. The Botany Club, botany is just plant life, members are designing a rectangular garden for the courtyard of this school. They plan to place edging on the outside of the path. How much edging material will they need? So this is telling us that they want edges around this outside area here. All right. Well, let's talk about how we can figure this out. Well, they give us some initial information in this diagram. I know that this distance right here is 16 feet. All right, and they also show us up here that 4 feet is the distance from the edge of the garden to the end of the edging. So how I can use that information is I now know that to complete this drawing that this is 4 feet, and also here on this outside, this is 4 feet as well. So if I wanted to draw a secondary diagram to help us conceptualize this, I now know the base is 16 plus 4 plus 4 to give us here 24 feet. All right, as well as, if you want to think of it up here, this is 24 feet as well. All right, and we can do a similar concept to determine the perimeter of this other outside edge. We know that this distance here is 22. And then similar concept, the extra distance here is another 4 feet. The extra distance here is another 4 feet. Adding that entire length up together, 22 plus 4 will give us 30 feet here, which also implies that on the other side we have 30 feet as well. All right, now the perimeter is very easy. We are just adding up these outside edges. Right, and you can either add up all 4 of these individually, that would work, or you could use the formula for perimeter, which is 2 times your base. So we have 2 times 24 plus, let me close this off here, plus 2 times our height, which is 30. Now, when I calculate this, or adding all of them up individually, which would still get us the same answer because perimeter is just the outside edges, we will get 108 feet, all right, and it's just feet because we're talking about perimeter, as our answer. All right, so let's move on to, we just did perimeter, of now finding the area of a rectangle. You want to make a rectangular banner. And that's going to give us some dimensions. Then we can draw a picture. The picture doesn't necessarily have to be to scale. It's just going to help us visualize the scenario. So it says it's going to be 2.5 feet wide. All right, so here is our 2.5 feet wide. Which we talked about how we won't really use mixed numbers that often in here. So you might want to just think about this as a 2.5. And then it says the banner is 5 feet high. All right, so really to encompass this, all we're going to need is this information. I could fill in the rest of my diagram, but the formula is just base times height. So to find the area, well, we've got our 2.5 multiplied by our 5. All right, and go ahead and get used to the concept of when I'm dealing with area, we're going to want our answer in feet squared, square feet. When I multiply the 2.5 and the 5 together, we get our area of 12.5 feet squared is the area of that banner. One thing that you will work on is keeping in mind what your answer is, and then that'll impact your, oh, you know what? Looking back on this, I want to change my question. It says to the nearest square yard. We may convert between units another day. I'm not going to do that. To the nearest square foot. All right. That takes care of that. So there's a little bit about our dealing with rectangles, and squares are very similar as well. Let's move on here now to talk about circles. You can name a circle with this symbol, which is a circle with a dot in the middle, and the capital letter that represents its center. So for example, a circle with center A is written, there's our circle symbol in A. Formulas for circle involve a special number called pi. So pi is the ratio of a circle's circumference to its diameter, and it is irrational. That means the decimal never ends, nor does it ever repeat. And we may talk about more about pi as we're going on through the year with extra time to kind of see where it comes from and how it works. All right. So pi can be approximated as 3.14 or 22 divided by 7. That'll give us a very similar number to work with if you want to work with a fraction instead of a decimal. You can use the pi button on your calculator for another approximation. The way to get that button on our calculator, if you're working on a TI, is you'll have to push second first, and then if you find the button that looks like this, it's a little up arrow caret. It's above the division sign on your calculator. You'll see that above it in another color, you'll have the pi symbol. All right, so it's not the directional button. It's the button above the division button. If you push second and then that, you can get pi onto your calculator. All right. If you have pi in your answer, then we say it is an exact answer, such as 3 pi. Now, this is just like when you're working with square roots, leaving an answer in a square root. That way we don't have to deal with the decimal. It's the exact answer. So, for example, 3 square root of 5 would be the exact answer. Just like if I wanted to say something was 3 pi, I could do it just like that instead of multiplying the 3.14 by the 3. All right, so finding circumference. So we've got the question here is, what is the circumference of the circle in terms of pi? Oftentimes they'll ask us just for this exact answer. They don't want it in decimal form. They'll allow us to leave it in pi form, which makes it very simple to do. Here's our circumference formula if we're talking about radius. Here's our circumference formula if we're going to be working with diameter. And so using both of these formulas will make this process very easy. Remember, diameter is just the distance all the way across the circle through the center. So the circumference of circle M, notice the circle with a dot in the middle, M, denoting our circle, is just as simple as saying pi times my diameter, which is 15. Now, the only thing is, you'll often see, instead of pi times 15, get used to placing that constant first. So even though it doesn't match the formula perfectly, 15 pi is that answer. And you'll see it listed like that instead of pi times 15. They are equivalent, but we like to put that coefficient out front. All right? Then what you'll want to look at on a situation like this, they didn't give us our diameter, they gave us our radius, so we'll need to incorporate that into our formula. So we have 2 times pi times r, which in this case is 4. But I'm going to simplify my answer. I'm not going to deal with the pi, but I can multiply this 2 and 4 to get an 8. So the answer here is 8 pi. All right, finding circumference not a big deal, especially when we already know our radius and diameter. So now, what if it asks us the same question, but now it wants us to round to the nearest tenth? That's just going to be taking our answers from above. So we got 15 pi, and we've got 8 pi, and using our calculator to physically multiply those two things together. All right? Now, rounded to the nearest tenth, we talked about up here you can approximate pi to 3.14 or 22/7. That's what you'll do if you're working on a calculator that doesn't have pi. Most of them do. But for this one here, I'm going to actually multiply 15 and pi on my calculator. And when it says round to the nearest tenth, let me show us what that means. My initial answer when I do 15 times pi is 47.12. All right, tenths is my first decimal spot. So I need to look at the spot behind it. Is it 5 or larger? 2 is not 5 or larger. We'll cross it off. We won't round up. 47.1 would be my answer because that was 15 multiplied by pi. All right. Now for this one here, I would do 8 multiplied by pi. And on this one, I would get a 25.13. 3 is not 5 or larger, so I will not round up my 0.1. Here is my answer. Right now, this 47.1 and that 15 pi are equivalent, essentially. The 15 pi, though, is that exact value. 47.1 is rounded. We lost some value there in our decimal, which is a very small number, but it's often nice to work with exact numbers like 15 pi, especially later in the year when we are working with, we'll be taking our answers and then doing more things with them. All right. So one last page here for us. Back on our last page. So back here, I'm going to go ahead and label our units. We have inches. Here, this one was talking about centimeters, 8 pi centimeters. And on this one, too, we would want to include that unit in our answer. Sorry about that. It's very easy to leave units behind, but they are important. All right, now this time it's asking us for the area. So we'll want to make sure we bring in our formula of pi r squared, where just the r is being squared. Notice on this example that they gave us the diameter. We don't need the diameter, we need the radius. The radius is only half of our diameter. So if the entire distance is 16, our radius is 8 meters. All right? Now, seeing this reminds me, and it's very easy to do, that we have forgotten our units. All right, so we have our radius of 8. Now we can use our formula where we have pi r squared. Okay, so 8 squared is 64. I'm going to move it to the front. So we've got 64 pi. And our unit is meters squared because we're talking about area, which is all of this. It's in 2 dimensions, not unlike perimeter or circumference, which is just regular units. Okay? So there we go. And like I said, tomorrow we'll be getting more practice on this. So today is just getting us the notes. This stuff's type of problem there is, I find interesting. Find the area of an irregular shape. Area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. So what that's saying is we have a diagram here. We can find the area of it by breaking it off into different segments that I can find the area altogether. So the area of this segment plus this segment plus this segment will be the area of the entire shape, which should make logical sense to us. All right, and taking these down is just a step-by-step process. All right. First question is, what is the perimeter of the figure? And it's telling us that all are right angles. It's also bringing in some other markings. When I see this, I know that these two sides are congruent. That tells me that this whole base is 9. When I see that all these 1 tick marks, that's telling me here that all of these segments are 3. So now all we have to do is go through and add up every single one of these numbers, right? And so what I mean by that is add up the 9 and this 9 and all these 3s, and that will tell us our perimeter. You can make this a little easier on yourself, kind of make it step by step by making it as, well, 9 plus 9 is 18, plus, then I've got, it looks like 1, 2, 3, 4, 5, 6 3s. So I can multiply 6 and 3, which is also 18. So 18 plus 18 gives me a perimeter of 36. My unit here is centimeters. All right. Now, for the area, we're going to want to break this apart into different pieces. Right, so I'm going to do it like this. We're going to break them into squares. We can find the area of squares. So the area of this top square would be multiplying its base, or the side by a side. So 3 squared. This came from 9 because 3 times 3 is 9. Now, this larger square here, its dimensions have changed. I've got this piece here and this piece here. Now keep in mind that if this is 3, the remaining length here must be a 6. This one is also a 6, which would tell me the area of this square when I multiply 6 and 6 is 36. And then this last piece is another 3 by 3 square. 3 times 3 is 9. So my area is going to be the total of these 3 added together. I got my 9, my 36, and my 9. So 36 plus 18, which is 9 and 9 together, gives us an area here of 54. I know my unit's going to be squared, and we have centimeters, so centimeters squared. All right, so this one here is a good problem, right? And we'll want to take this down also in a step-by-step process. And the key is breaking it into shapes that you know and that you can find the area of. So here's what it would look like, at least how I would do it. I'm going to break it across here, right? And then you can kind of label yourself your new dimensions. This segment here would have to be 8, right? Because the whole thing is 10, right? And then we can see up here that this missing segment is right there. And so if this one is 10, when I break this off, that this piece has to be 2. So this would be a 2 right there. Okay? Because it had to all equal out to our 10. All right, and then from here, we could do this. Another dividing line here, which would tell us that this segment right here is 2 because it's the same length as that segment right there. So just using the diagram to get it labeled. Which then leaves us with the question of, well, what would this segment here be? Well, and when you're doing these, they're not often going to land to scale, and that's okay. This is 4 centimeters. And I know that this piece here, because it matches this piece, has to be 2, which implies for this tallest piece to equal out to 4, that also has to be 2. Okay? So now I'm good to find the area of these different pieces. Now, it's not going to look right. This is technically a square according to our dimensions of 2 all the way around. Doesn't look like a square, but that's okay. It's not drawn to scale, which a lot of the times will happen. The area of this largest rectangle, 8 times 4 here. All right, so this is 32 centimeters squared. Area of this square, 2 times 2, 4. Now triangle, we haven't seen yet, but we've got the formula. it'll be 1/2 base, which is 2, times height, which is 2. And then we multiply it out. 1/2 times 2 is just a 1. 1 times the remaining 2 tells me that the area of this smaller triangle is a 2. So the area would be 2 plus 4 to give us 6. 6 plus 32 would give us 38. And we're working with centimeters squared because we're speaking on area. So we've seen a variety of things here. What you can use the remaining time on is get some practice, start looking at the homework posted on the weekly agenda. I will be back for us tomorrow. We can answer questions on this, especially if I made any mistakes during this video. We're not going to get any new information tomorrow. We will just look back over this, work together in groups most likely to piece this information together and have a good understanding of it.